Okay, so we're working through the dot product problems. This should be fairly review-ish because this is something that we covered in ACalc, and we're just kind of bringing it back around because the dot product is an example of the inner product, which we'll be discussing over the next several classes. So we're given that in problem number one, we want to find a vector that has a magnitude of 2, but in the direction of the same direction as the vector u. So the first thing we need to do is we need to find the magnitude of u. Okay, so to do that, we take its components, square root of 3 squared, plus 3 squared plus 0 squared, and then take the square root of the sum of those. This is going to give me a square root of 3 plus 9 plus 0, which is the square root of 12, which we can say is 2 radical 3, right? This means that v should be the u vector divided by its magnitude, 2 radical 3, times 2, because that's the magnitude we want. So this is times the u vector, which is 3 radical 3, 3, 0. A little bit of work with this. The 2's cancel, so that's going to give me 1 over radical 3. So if I distribute that, scale multiply here, I'm going to get 1, 3 over the square root of 3, 0. I can pretty this one up a little bit. Multiply top and bottom by the square root of 3, which is just going to give me radical 3 times 0. So there you go. That's problem number 1. Let's move on to number 2. Okay, so problem 2 works the same way that problem 1 did. We take the magnitude of u. This time I have 4 components, so I'm 0 squared plus 2 squared plus 1 squared plus negative 1 squared. So that's going to come out as 0, 4, 1, 1, which is the square root of 6. So v should take u and divide it by the square root of 6, and then multiply it by the magnitude I want, which is 3. So I did the work out front this time. This is going to give me 3 root 6 over 6 when I start rationalizing, which is root 6 over 2. And then once I do the scalar multiplication, I'm going to get 0, root 6 over 2, and negative root 6 over 2. So that's problem number 2. All right, so for 3 through, I think it's 8, we're working with u being 1, 1, 2, and v being negative 1, 3, 0. The first question is what do I get if I dot those? So it's going to be 1, 1, 2, dot, negative 1, 3, 0. So that's going to be negative 1 plus 3 plus 0 makes that 2. So that's problem number 3. Let's do problem 4 is u dot u, which is 1, 1, 2 dot 1, 1, 2. So that's going to be 1 plus 1 plus 4, which is 6. All right. Problem 5 asks me what is the magnitude of u squared, which is the same as u dot u, which is 6. Number 6. All right, so we're going to take u dot v times v. So from above, we have that u dot v is 2. V is negative 1, 3, 0. So this should come out as negative 2, 6, 0. All right. For number 7, we have u dot 2v. So this is going to be 1. Well, this is actually, I can play this off of the one I just did, or one above there, right? Because this is the same as 2 times u dot v. 2 times u dot v is just going to be negative 260 again. So that one wasn't so bad. Or no, sorry, that's not correct. No, 2 times u dot v is just going to be 2 times 2, which is 4. All right, so let's look at number 8. 8 asks for what is the distance from u to v, which is the same as the magnitude of u minus v. U minus v, so this is going to be the magnitude of 1, 1, 2 minus negative 1, 3, 0. It's just the magnitude of, let's see, 1 minus negative 1 is 2. 1 minus 3 is negative 2. 2 minus 0 is 2. So this is going to be square root 2 squared plus negative 2 squared plus 2 squared, which is 4 times 3 is 12. So that's going to be 2 radical 3. All right, so let's look at the last couple here, and we'll be done. All right, so these two are playing around with the distribution property. U plus v dot 2u minus v. So let's do this as u dot 2u minus v plus v dot 2u minus v, which is 2u dot u minus u dot v plus 2u dot v minus v dot v. And all of these values are given to me, so this is 2 times 4 minus negative 5 plus 2 times negative 5 minus 10. So let's see, this is 8 plus 5 minus 10 minus 10. That's 13 minus 20 is negative 7. All right, so that's number 9. Let's look at number 10. Number 10 says take 3u minus v dot u minus 3v. All right, so we distribute again. So we're going to get 3u dot v, sorry, u, 3u dot u minus 3v minus v dot u minus 3v. All right, so this is 3u dot u minus 9u dot v minus u dot v plus 3v dot v. So this should be 3 times 8 minus 9 times 7 minus 7 plus 3 times 6. So 24 minus 63 minus 7 plus 18, I think comes out as negative 28. All right, so those are the dot product problems, and we move on from there.